Electrochemistry. Electrochemistry deals with chemical reactions produced by an electric current. There are two kinds of electrochemical cells. There are electrolytic cells, which use energy to cause non-spontaneous reactions to occur, and there are voltaic cells, in which spontaneous reactions produce electricity. All electrochemical reactions are oxidation-reduction reactions. We have the loss of electrons, which is oxidation, and we have the gain of electrons, reduction, that occurs simultaneously. Electric current can be conducted through metal wires or along metal surfaces and through pure liquid electrolytes. Electrolytes are a substance that, when put in water, is able to conduct a charge. So in this diagram here, we have our electrolyte in solution. It's able to conduct the charge, and we have our electrodes, our negative and positive electrodes, which are just metal surfaces upon which oxidation and reduction can occur. So we have the cathode, which is the electrode at which reduction occurs, and we have the anode, which is where oxidation occurs. This is how I remember cathode from anode. Red cat, reduction, cathode, and ox, anode, oxidation. Also, remember, Leo says Ger, loss of electrons is oxidation, and the gain of electrons is reduction. We're first going to look at voltaic cells. These are cells in which spontaneous reactions produce electrical energy. For example, a piece of zinc is immersed in copper sulfate solution. So we have zinc metal immersed in copper sulfate. I'm going to omit the sulfate because it's a spectator ion. It's going to produce zinc with a 2+ charge and copper. So in this case, zinc is oxidized. Zinc goes from no charge to 2+. Copper is reduced. Copper gains electrons, goes from Cu2+ to Cu with no charge. However, in this system, no useful electrical energy can be produced. Instead, the two halves of the redox reaction are separated, so electron transfer is forced to occur by passage of electrons through an external circuit. We call these two halves half cells. So consider a standard cell that consists of two half cells, one with a strip of copper immersed in copper sulfate, and the other with a strip of zinc immersed in zinc sulfate. So we have our two half cells. We have our zinc electrode and our copper electrode immersed in their appropriate solutions. They're connected by a wire hooked up to a voltmeter, which measures the potential difference, and the solutions are connected by a salt bridge. Now, a salt bridge is just some medium through which ions can pass and maintain charge balance. A salt bridge is nothing more than a glass tube that's filled with salt, like KNO3 or sodium chloride. It's just a glass tube that's filled with salt that will maintain charge balance. The initial voltage is 1.1 volts. The copper electrode gains weight. The zinc electrode loses weight. So what you have at the anode looks like this. Zinc goes from Zn with no charge to Zn2+, plus 2 electrons. This is the anode. This is where oxidation occurs. At the cathode, we have Cu2+, plus 2 electrons, going to form copper metal. This is the cathode. This is reduction. Overall, if we get rid of the electrons and combine the half reactions, we get an overall reaction that looks like this. Electrons will always flow from the anode to the cathode. And that salt bridge will maintain charge balance. So 2 Cl- ions from the salt bridge will migrate into the anode for every Zn2 plus ion formed. Simultaneously, 2 K plus ions will migrate to replace every Cu2 plus ion reduced. So that salt bridge maintains that charge balance. In shorthand form, here's what this cell looks like. We start off at the anode, which is zinc, and we end up at the cathode, which is copper. So here's the anode, where oxidation occurs. Here's the cathode, where reduction occurs. Here in the middle is the salt bridge, which is that glass tube filled with salt that maintains charge balance. And then we have our solutions right here that are in contact with the salt bridge. So that's shorthand form for a spontaneous cell, a voltaic cell.